This video is on section 9.2, outcomes and the type 1 and type 2 errors. So when you perform a hypothesis test, there are 4 possible outcomes depending on the actual truth or falseness of the null hypothesis, H0, and the decision to reject or not reject the null hypothesis. So we have these situations where H0 is true, but you reject the null hypothesis. That's called a type 1 error. If the null hypothesis is false and you reject the null hypothesis, well, that's the correct thing to do. If the null hypothesis is true and you do not reject it, that is also the correct decision. But then if the null hypothesis is false and you do not reject it, that is called a type 2 error. So there's 2 situations where H0 is false and you reject it, that's good, or it's true and you do not reject it, that is also good. But you have these 2 different types of errors depending on which situation you're in. So each of the errors occurs with a particular probability. Alpha is the probability of a type 1 error, and beta is the probability of a type 2 error. So we've seen alpha before. Beta is the Greek symbol. It's kind of like a B. So alpha is the probability of rejecting the null hypothesis when the null hypothesis is true. That's a type 1 error. Beta is the probability of not rejecting the null hypothesis when the null hypothesis is false. That's a type 2 error. Alpha and beta should be as small as possible because they are probabilities of errors. They are rarely 0, but we're trying to get them as small as possible. 1 minus beta is called the power of the test. Ideally, we want a high power that is as close to 1 as possible. Increasing the sample size can increase the power of the test. So if beta is the probability of not rejecting the null hypothesis when the null hypothesis is false, 1 minus that, remember, would be the rest of the probability. So rejecting the null hypothesis when the null hypothesis is false. So example 9.5, suppose the null hypothesis, H0, is Frank's rock climbing equipment is safe. A type 1 error would be Frank thinks that his rock climbing equipment may not be safe when in fact it really is safe. So he rejected the null hypothesis, but it was true. A type 2 error, Frank thinks that his rock climbing equipment may be safe when in fact it is not safe. Alpha is the probability that Frank thinks his rock climbing equipment may not be safe when in fact it really is. And beta is the probability that Frank thinks his rock climbing equipment may be safe when in fact it is not safe. The error with the greater consequence in this situation is the type 2 error. So if Frank thinks his rock climbing equipment is safe, he's going to go ahead and use it. And if in fact it is not, that is not a good situation. So some of our examples in this video show you the type 2 error is the one with greater consequence, but it's not necessarily always the type 2 error. Sometimes it's the type 1 error. So try it, 9.5. Suppose our null hypothesis, H0, is the blood cultures contain no traces of pathogen X. What are the type 1 and type 2 errors? Type 1 error, we think the blood cultures do contain traces of pathogen X, when in fact they do not. Type 2 error, we think the blood cultures contain no traces of pathogen X, when in fact they do. Again, alpha is the probability that the blood cultures do contain traces of pathogen X, when in fact they do not. And then beta is the probability that the blood cultures contain no traces of pathogen X, when in fact they do. So which error has the greater consequence? Again, in this situation, it's the type 2 error. If we think that the blood cultures contain no traces of pathogen X, then we don't treat the patient when in fact they need the treatment. Example 9.6, suppose the null hypothesis H0 is the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. The type 1 error is the emergency crew thinks that the victim is dead when in fact the victim is alive. Type 2 error, the emergency crew does not know if the victim is alive when in fact the victim is dead. Alpha is the probability that the emergency crew thinks the victim is dead when in fact the victim is really alive. And beta is the probability that the emergency crew does not know if the victim is alive when in fact the victim is dead. Here, the greater consequence is the type 1 error. If the emergency crew thinks the victim is dead, they will not treat him. Okay, so it's not always the type 2 error, right? So you just have to think about what the errors mean and then, make a decision on which one has the greater consequence. Try at 9.7. This one's a wordy one. Red tide is a bloom of poison-producing algae. When the weather and water conditions cause these blooms, shellfish such as clams living in the area develop dangerous levels of a paralysis-inducing toxin. You may have heard about this in the news. They'll say that the red tide is occurring. So in Massachusetts, the Division of Marine Fisheries monitors levels of the toxin in shellfish by regular sampling of shellfish along the coastline. If the mean level of the toxin in clams exceeds 800 micrograms of toxin per kilogram of clam meat in any area, clam harvesting is banned there until the bloom is over and the levels of toxin in clams subside. So what are the type 1 and type 2 errors in this context, and which one has a greater consequence? So our null hypothesis is that the mean level of toxins is at most 800 milligrams. So H naught, and then M naught, so the mean value, our null mean value, is less than or equal to 800 milligrams. That's considered safe. So a type 1 error would be that we think the mean level of toxin is greater than 800 milligrams when in fact it is not. And a type 2 error is we think the mean level of toxin is not greater than 800 milligrams when in fact it is. Which one of these two has a greater consequence? Well, the type 2 error has a greater consequence because if you think the toxin level is safe, but it's not, then maybe people are eating the clams and, getting paralyzed. Sounds terrible. Again, so you have to think about what you're looking for, your null and alternative hypotheses, well, your null hypothesis, and then you think about your errors and which one has the greatest consequence. So that's section 9.2.